Okay, here is part 2 of how to graph a quadratic function, right? So here's your summary page that we talked about in the last video, where we said if you want to graph a quadratic, if you want to graph this parabola, then we are going to calculate 5 key points, right? And in the last video, we talked about the axis of symmetry, which is the line that cuts down the middle of the parabola, this vertical line, right? And we talked about the vertex, which, depending on the form, you either need to calculate using negative b over 2a, or if it's in vertex form, you can just use the h value, right? That's kind of how we decided on those, right? So now we're going to talk about the rest of the points here, the x and y intercept points, and this last one called the point symmetrical, and then we're going to put all that together onto the graph and see where we end up, okay? So let's get to I believe it's right here. There you go. Okay. So calculating the x-intercepts of the parabola. Okay. So here's the way x and y-intercepts basically work. Okay. So for the x-intercepts, what we know is that every point that is on the x-axis, or let me draw a quick axis here. Every point that is on this horizontal axis, the x-axis, okay, is always something comma 0. So for example, this point right here is 4 comma 0. If I come over here a little bit, this one is negative 2 comma 0, right? If I came way over here somewhere, this one might be like negative 10 comma 0, right? So what we know, the only thing we know about every point that is on this x-axis is that the y value of all of them is always 0, right? So that's why up here I'm telling you to calculate the x-intercepts, set the y value equal to 0. Or in some cases, like number 2 here, sometimes y can be referred to as f of x, but same thing, right? We're not going to set x equal to 0. We're going to set the output variable to 0. So what we're going to do is number 1 and number 3 here. Number 2 is kind of similar to number 1, so we won't do that one, right? So I'm going to set this y value to 0. I'm just going to say 0 equals x squared plus 7x plus 12. Okay, so I made my y value 0. Now I'm going to solve this, right? So you're going to use whatever solving method is most appropriate for this particular problem. Remember, our options are factoring. We could use the square root method. We could use completing the square, or we could use the quadratic formula, right? Depending on the situation, some of them are better. Some of them don't work at all, right? So in this case, let's start off with factoring, right? This one, if I say, are there numbers that multiply to 12 that add to 7? The answer to that's yes. This is 4 times 3, and 7 is 4 plus 3. So I can quickly break this up into an x plus 4 and an x plus 3, okay? And I have an equal 0 on the other side, right? So I factored, and so now I can set my factors equal to 0. X plus 4 equals 0, or x plus 3 equals 0, okay? And then if I solve each of these, I'm going to get two numbers. One is a negative 4. The other one is a negative 3. Okay. So here's what this means, right? When I get these two answers, negative 4 and negative 3, for both of these x values, the output is 0. So what that tells me is that I have two x-intercepts. One of them is an x value of negative 4, a y value of 0. The other one is this other x value of negative 3, which also outputs 0. So I have two values where it crosses the x-axis, which is negative 4 and negative 3. Okay? That's all you got to do, right? So these are really just solving equations in disguise, right? So when I come down to number 3, same idea. I'm going to find the x-intercept of this particular equation. So I'm going to start off by plugging in a 0 for the y value. Okay, and I'm going to say x minus 4 squared minus 18. Right, so this one is, I'm going to solve it, right? This is just a solving problem like we recently did with just solving quadratics, right? So we're going to look at this one and say this looks like a good square root method problem. So I'm going to add the 18 to the other side. Okay, and it's going to be 2x minus 4 squared. Okay, I'm going to get rid of this 2 by dividing it away, right? Dividing by 2 on both sides. And I get 9 equals x minus 4 squared, right? And now that the squared is by itself, we can square root both sides. So I'm going to say square root, okay? And I'm going to wrap this up by saying the square root of 9 is 3. Squared and squared cancel, okay? So that gives me an answer. I'm going to add the 4 over. That's a 7, okay? So I'm usually expecting a second answer, and so what you may have forgotten is that when I square root 9, not only do I get 3, but I also get negative 3. So I'm going to write a second equation where the output might be negative 3. If I add 4 to this one, I get a 1. Okay. So again, what we're claiming is that for this equation, right, if I were to draw the parabola, right, that goes along with this one, I'm going to say that there is an x-intercept at 7 comma 0, and there's another x-intercept at 1 comma 0. Okay, and those are your two answers, right? So to calculate x-intercepts, set y equal to 0, pick the appropriate solving method. Okay, and then once you have these answers, don't leave them as x equals -4. That doesn't mean anything. If I'm trying to find an x-intercept that is a point, and in this case it is whatever that x value is, comma, 0. Okay, so that's the x-intercepts, right? So we now have the vertex and the axis of symmetry. We can put those on a graph, right? And now we have two additional points, usually, right? The two x-intercepts, right? So we have two more that we have to find, okay? So the next one is the y-intercept, okay? So to calculate the y-intercept, this one's actually easier. We're still going to plug in a 0, but instead now we're going to plug the 0 in for x, and we're going to find y. And again, you might be thinking, well, why are we plugging in a 0 for x? I'm glad you asked. Let's look, right? If I look at my my axis again, if I think about points on the y-axis, since we're finding a y-intercept, right? Points on the y-axis are always, right, in this case, 0, 4. If I come down here, this one is 0, -2, right? These are all points where the x value is 0, and the y value is whatever I want it to be, right? So I'm going to use these same two problems, number 1 and number 3. The nice thing with these ones is I'm just going to say y equals, and I'm going to plug in a 0. 0 squared plus 7 times 0 plus 12. Okay, so this is 0 plus 0 plus 12. Y is equal to 12. Okay, so I just found out that when I plug in a 0 for x, my y becomes 12, and that means that I have a y-intercept at 0, 12. Okay, and I made a little note up here. In standard form, which number 1 is in standard form, there are no parentheses. Okay, the y-intercept is always the c value. Okay, this is a quick hint for you. Okay, and if you notice, there's your c value, and I got a 0, 12, right? And that lines up. And this is just because when I plug in a 0 to these first two terms, they just go away, right? 0 plus 0, right, is just leaving behind the c value. Okay, so that's just a quick little shortcut that you can use for standard form only. Okay, so let's look at number 3, which is not in standard form. This is in vertex form. Okay, if I plug in a 0 here, I'm going to say 2, 0 minus 4 squared minus 18. Okay, be careful with your PEMDAS here. We have to do 0 minus 4 first. That's -4 squared. Okay, and again, here's where I would say careful with the PEMDAS. Okay, we are not going to do 2 times -4 first. We have to do the squared first, right? This looks like 16, right? -4 times -4, okay? And then I can make that look like an 8, okay? And then I can do 2 times 16, which is 32, minus 18, and that looks like it leaves 14 behind, right? So in this case, my y value, when I plugged in a 0, is 14. Notice that is not this end value, right? It does not work like standard form. Right? This value at the end is not the y-intercept. It's 14, right? So I'm going to say in this case, I plugged in a 0. I got back a 14. The y-intercept of number 3 is 0, 14. Okay? And that's all there is to it, right? So x-intercepts, you're plugging in a 0 for the y and solving for x, right? For the y-intercept, you're plugging in a 0 for the x, and then you're solving for y. Okay, so now let's put all this together, right? We're going to take a look just at one problem. We're going to graph all of these points, and we'll talk about the symmetrical point, right? You can kind of see I have a little note at the bottom here that a symmetrical point is a point that is the same distance, but on the other side of the axis of symmetry. So what we're going to do is we are going to find the y-intercept, and then we're going to reflect it over the axis of symmetry, and that's going to give us our 5th point. So again, nothing to calculate. Okay, so let's start off. We're just going to do this problem here and one more in vertex form, right? And then we're going to answer a question about this. In this case, what is the domain and range? Okay, so calculating the vertex, right? So if I get this equation, we said x equals -b over 2a. This one's in standard form, so I got to do the formula for the axis of symmetry and the vertex. So if I plug in -3 over 2a, or a is 1. Okay, that looks like -6, okay, over 2a. Okay, so we'll end up getting -6 over 2 times 1, which is -3, right? So what we know is two things, right? Before we even get into the rest of the vertex, we know that if we go over to -3, right, and we kind of make a little dotted line going up the middle of this, we know that this graph is going to be centered on this dotted line. This is the axis of symmetry. And we'll use this again to do the rest of it in a second, right? So -3 is my x value, and that means that I also know for my vertex point that it's going to be a -3 comma something. In order to figure out the something, we're going to plug in -3. So our y is equal to, okay, -3 squared plus 6 times -3. always hit the button on my pen here. Okay, plus 6 times negative 3 plus 8. Okay, so if I simplify this, it looks like I get a 9 minus 18 plus 10. Okay, or plus 8. Okay, 9 minus 18 is negative 9. Negative 9 plus 8. Okay, let's get rid of that, make it look nice, right? So negative 9 plus 8 is going to be negative 1. Okay. So it looks like when I plug in a negative 3, I get back a negative 1. Okay, and that's my vertex. There's 1 point done. Okay, so I'm going to put that one on my graph. Negative 3, negative 1, that's right here. Okay, now I'm going to calculate my x-intercepts. We just said a moment ago that to calculate x-intercepts, you're going to plug in a 0 for y. So I'm going to say 0 equals x squared plus 6x plus 8. Okay, and I'm going to solve this one. Again, this is a nice factoring problem. There are numbers that multiply to 8 that add to 6. So I'm going to say this is x plus 2 and x plus 4. Okay, and I can set each of these equal to 0. When I set this one equal to 0, I'm going to get negative 2. When I set this one equal to 0, I'm going to get negative 4. And so I have two different answers, x equals 2 and x equals negative 4, right? And that's going to give me my two x-intercepts, right? So we're going to plot these, negative 4, okay? So I got a point negative 4, 0, right? That was my input, my output. And I have a negative 2, 0, okay? And if I graph these, here's what I get, right? Negative 4, 0 is right here. And negative 2, 0 is right here, right? And this is a really good result, right? Because this looks like it's going to be still centered on this axis, right? And remember the whole idea of symmetry that I just mentioned is that there should be a point the same distance on both sides of this line. And my x-intercepts, I have a point that is 1 unit to the right, and I have another point that is 1 unit to the left. That is a good way to check to see that you have the right x-intercepts. If you don't have 1 point on both sides of this line at the exact same distance, then that means you did something wrong, right? And you want to go back and look at your work, okay? All right, let's do this last one. It says plot the y-intercept and reflect it over the axis of symmetry. Okay, so we said to find the y-intercept, we're going to plug in zeros for x and figure out what y is. So this is going to be y equals 0 squared plus 6 times 0 plus 8, okay? And hopefully you might have remembered that in standard form, I can just look at this last number because 0 plus 8 is just 8. So I plugged in a 0, I got back an 8. That means that if I go to this graph and I plot 0, 8, which is up here, okay, that is point number 4, right? If this is called the 5 key points, we have one left to do. This is the new one. Okay, so what we're going to do to reflect a point over the axis of symmetry is we're going to look at this point. We're going to say, how far is the y-intercept from this axis line? So if we count 1, 2, 3 units, it's 3 units away. I know that there's another point 3 units on the other side. So if I go 1, 2, 3, here it is. Okay, this is my last point, right? And I can say that that's the point negative 6, 8, right? So I can get one more point, which is just a reflected point, right? And now I'm going to sketch this, and it's going to look something like this, okay? And there's a nice parabola for you, okay? As ugly as my parabolas are with this pen, okay? And that's it. We did it, right? We graphed the parabola. We calculated all 5 points, right? We have this nice U shape. Now, if we wanted to answer one last question, if someone says, what is the domain and the range of this function, right? That's not too bad to ask. So we're just going to do that down here. So we're going to talk about the domain first, right? So if I look at this graph, okay, I'm going to say that this looks like it's going up and to the left and up and to the right forever. Right? So if I say up and to the left and up and to the right, it sounds like it's going left and right forever, and that means we're covering everything. So the domain is going to be everything from, not curly braces, parenthesis, negative infinity to infinity. Okay? So that's going to cover everything. And here's a nice little hint for you again. When I ask you what the domain of a quadratic function is, any quadratic function ever, it's always going to be all real numbers. Okay? There are no restrictions on what we're allowed to input into a quadratic function, so the domain will always be everything, negative infinity to infinity. Okay? The range, however, is not everything for sure, right? So we're going to say the range, okay, is going to be, if I take a look at this graph, it looks like it goes as low as -1 and everything above that, right? So the way that I'm going to write that is it's starting at -1 with a square bracket, okay, and then it's going up forever to infinity, which remember always has a round bracket. Okay, and if you notice, and this is not a coincidence, the y value is -1. My range is restricted at -1, right? That is the turning point. That is where it's at its minimum, and then it turns around and goes back up, okay? So this range number will always be associated with the y value of the vertex because that's literally the lowest point on the graph, and that's going to be reflected in this range value, okay? So that's all there is to it. We have axis of symmetry and vertex, right, to get that middle point. We have the x-intercepts, which is just solving quadratics. We have the Y-intercept, which is plugging in 0 and coming out with something depending on which version you're using. And then we can reflect that Y-intercept over the axis of symmetry. Once we're done, we can use the graph to find the domain and range.